what exactly is a superconductor and why is a room temperature one so important? Well, it all comes down to energy and heat. When we talk about electricity, what we're really talking about is the flow of electrons through a material like a wire from point A to point B. But it's not always that easy for these electrons to flow because they're constantly interacting with atoms within that wire along the way. And all these interactions create a kind of internal friction known as electrical resistance. And kind of like how your hands get hot when you rub them together due to friction, this electrical resistance creates a load of waste heat too, which is why things like phones and laptops often overheat if you use them too much. And all this waste heat really adds up. In fact, it's estimated that between 5 to 10% of all the electricity we send down the grid gets wasted by it. And that adds up to costs of around $20 billion per year in the US alone. Now, back in 1911, a Dutch physicist discovered something astonishing. He was playing around with the metal mercury to see how its resistance would behave at really cold temperatures. He reasoned that because resistance is caused by vibrating atoms, and atoms vibrate because of heat energy, then if you made the metal colder, its resistance should gradually decrease too, down to some finite value. But instead of doing that, suddenly, at just 4.2 degrees above absolute zero, the mercury's internal resistance disappeared entirely. For some strange reason, below that critical temperature, the mercury became a literal perfect conductor, to the point that if you put a current through it, it would keep flowing forever and ever, like some kind of perpetual motion machine. He called this bizarre phenomenon superconductivity and in fact won the Nobel Prize for it 2 years later. And since then, we've discovered a number of different superconducting materials which we use in many kinds of cutting-edge tech like MRI machines, particle accelerators, even fusion reactors. We even use them to levitate stuff, thanks to a thing known as the Meissner effect, where a magnetic field is expelled so strongly outside of the superconductor it can even levitate trains. So yeah, superconductors are pretty much the coolest thing ever, and therein lies the problem, because unfortunately all the ones we're currently using require extremely cold temperatures to maintain, which means they use a lot of energy. And in fact, that's one of the reasons why MRI scans cost so much, because they need all this liquid helium, which is a resource we are rapidly running out of, to keep them cool at 4 degrees Kelvin, just a smidge above absolute zero. And even though tons of headway has been made in the quest for a room temperature one, still the best we've achieved so far is minus 23 degrees Celsius, so still well below freezing. And when you consider that still today over 60% of our electricity comes from climate change causing fossil fuels, you can see why this is a holy grail of physics.